What is up, weather enthusiasts? I'm your host, Pat's Path Predictor. Let's get right into the weather. Alright, so here's the situation we have for you, ladies and gentlemen. We have a lot to talk to you about today as we're watching some stuff going on in the Eastern Pacific that could enter the Bay of Campeche and cause some development over there. Also watching the main development region for a possible area of development in the next few weeks, according to some European ensemble climate runs. So we're going to be talking about that as well. So we have a lot to get through, so let's go ahead and dive right into it, starting with the National Hurricane Center. And here's what we have going on with Dalila. It is currently weakening right now. Maximum sustained winds are at 50 miles per hour as it moves further to the west. Pressure is 999 millibars, expected to become a remnant low in the next day or so, according to the cone, and then dissipate shortly thereafter. So this will probably be the last time we talk about Dalila, since it's kind of peaked out and it's kind of weakening pretty quickly at this current point. So that's pretty much a quick running down summary of what's going on with Dalila. Now let's go ahead and move on to Invest 94E, because this is what we're going to be talking about for quite some time because of the possibility of this entering the Gulf. So here we go. A broad area of low pressure continues to produce disorganized showers and thunderstorms offshore Central America. Environmental conditions are expected to be conducive for gradual development of the system, and a tropical depression is likely to form by the middle of the week while moving westward to west-northwestward just offshore the coasts of El Salvador, Guatemala, and southeastern Mexico. 40% probability in the next 48 hours, 70% in the next 7 days. So that's kind of what we have going on with 94E right now. We're slowly but surely starting to see those chances continue to increase with it right now. We're seeing it being tagged off the coast of Nicaragua and Costa Rica right here. So we're going to want to keep tabs on it. However, where the system ultimately develops, whether it's further to the north or south of that red X right here, will be critical on the track and the trajectory of that system right here. So let's go ahead now and shift over to the satellite imagery. And we're going to go ahead now and shift over to the Eastern Pacific before zooming in. But here's what we have going on. Dalila's weakening right now. Not going to talk too much about it. 94E, we're going to want to pay attention to going forward, because there's a couple things we need to keep a very close eye on. Number one, how the system's organizing, kind of where the center of the rotation is, and we're also paying attention to at least what the remnants of the outflow that Dalila is bringing over here, determining how much shear that this system over here off the coast of Central America is going to get. So let's go ahead now and zoom in on Dalila right now, not Dalila, but Invest 94E. So here's the situation that we're looking at right here. We're looking at potentially the area of convection. Actually, I'm going to go ahead and go to water vapor just to kind of get a better idea of where the rotation potentially may be. Where we're looking at right now, it looks like according to this, the center of rotation is a little bit further to the north compared to what we were seeing previously with the NHC going for it. Let's go ahead and show you that right here. Right now, it's about 9-ish, like 9.7, 9.8 degrees north at this current point. Where this is looking at right here, we're looking at maybe around like 10.5 degrees to the north, according to where that rotation may be. Now, you're probably asking yourself, Patrick, why are we looking at where the system is right now? Why are we looking at the potential development part? Why aren't we paying attention to the possible impacts of this? Well, where this system ultimately develops will be critical in determining what ultimately happens, what track it'll go, whether how strong it ultimately gets as well, and kind of if this enters the Gulf, or will it crash into land and pretty much be the end of that? Because if it crashes into Mexico and stays on shore, it's not going to develop into anything in the eastern in the Bay of Campeche, excuse me. So that's something we're going to have to pay attention to. Right now, the convection is a bit disorganized, but you can tell at least where some of the rotation is, or at least where the center of rotation, where that mid-level circulation is trying to develop, and it's further to the north than what the NHC has tagged at this current point in time. So we're going to want to pay attention to it. Taking a quick look at the long wave imagery right now. We saw some convection just fire off and then just die off pretty quickly. Mainly some more popcorn convection that I'm noticing as well. We talk about that quite a bit, where just convection just blows up and then calms down, then blows up, then calms down. It's pretty scattered in nature as well, so you're going to want to pay attention to that. But ultimately, you're going to want to watch how the system will evolve and how the system will ultimately begin to pan out. What I am noticing too is I am noticing a little bit of outflow trying to develop with this system right here, an indicator that the system's starting to become a little more healthy and the system is going to start breathing a bit more and allow for potential more development as well. So we're going to want to pay attention to how this will ultimately pan out in the next 48 hours or so, because if we're starting to see more convection that instead of maybe just is popcorning like you're seeing right here on screen, but instead is more consistent and is more kind of concentrated as well, then that's going to cause bigger problems in my opinion, because of that will also increase the intensity potential with this as well. So let's go ahead now and shift over to the models, because this is going to be very important, and we're kind of lumping this in kind of with what we're looking at with the Atlantic, because this does pose a dual threat, I would say, according to what I've been seeing, at least according to some of the ensembles as well. So let's go ahead and show you the operational runs just to show you what they've been going for so far, and then we'll shift over to the ensembles and then run from there. So here's what we have with the operational runs. Ultimately, the European has the system organizing and developing in about 60 hours. We're at tropical storm strength. Then it begins to intensify, gets down to a sub 1,000 millibar, 994 millibar system, potentially a hurricane as this crashes into Mexico right here. Then it weakens due to the mountains and land interaction, all that stuff. Then all that energy and all of that moisture reemerges off the Bay of Campeche. But the question is, will the low-level center be inland or will it be off to shore? Right now, the European is having a hard time figuring that out. And let's go ahead now and show you the ensembles just to kind of give you an idea of what we're looking at with this. Here's the 0Z ensembles right here, and we will go ahead and move these over just to kind of show you this, and we will go ahead and extend out to 240 hours out. So what the Europeans having a hard time figuring out is, if this crashes into Mexico, will it be further east and out to sea in the Bay of Campeche to allow for potential tropical development to take place, like some ensembles are showing, or will it be hugging right on the coast, and will there be a lesser probability of tropical development? That's the main thing we're paying attention to. And how the system will initialize and how the system will kind of, in terms of where the LCL will drop, will be pretty critical to determine what actually happens. So that's something to keep very close eye on. Right here, showed you the operational. We're now showing you the ensembles. We're going to go ahead and show you the GFS operational as well. We're going to go ahead and go to 0Z and 12Z just to kind of look at the difference as to what's going on. Then we'll get into the conditions and talk about it. Kind of like, okay, how is this backing up, and and how this also contribute to the threat in the Atlantic as well. So we're going to kind of merge a few sections together in today's video because of this threat right here. So what we have with the GFS, organizing, developing, intensifies pretty quickly, gets down to a 997 millibar system as it approaches the Mexican coast. So actually a bit more conservative than the European. Then it crashes into land, and it doesn't really do too much. It just hugs the coast of Mexico right here, and that's pretty much the last we will have from that. So let's go ahead now and shift over to the, okay, didn't mean to do that. Let's go ahead now and shift to the GFS ensembles right here. We have the 0Z, and we'll go out to 240 hours just to show you. Okay, I meant to do 240, and then we'll show you guys what we're looking at right here. Perfect. So here's what we have with the 0Z GFS ensembles right here. And I'll go ahead and move my camera over just so we can take a closer look at this. So here's what we have. The GFS ensembles are being pretty conservative with it, mainly keeping it out to sea. Like a lot of the runs, some ensembles have it splitting off into the along the coast of the western Mexico. Some of it having crashing into land and then moving into the Bay of Campeche. So we're having a bit of a hard time figuring out what exactly is going to be happening. Looking at the 12Z run right now, we have 240 hours out. a bit more scattered, I would say. So you're going to want to pay attention to it, but it looks like these ensembles want this system to hug the coast, with the exception of some European ensembles going forward. So how this system will develop and where this initializes will be critical in this case. If it initializes further to the south, then I will just say that development in the Bay of Campeche is less likely. If it develops a bit further to the north, like I've been seeing with the operational stuff that I've been noticing, then we might be a bit more into business. But here's what we have with the 12Z. This system starts to really organize. The GFS wants this to be a 981 millibar hurricane at 12Z that crashes into Mexico, and then ultimately, apparently the GFS has this kind of just jerking off to the west and hugging the coast like that, which I don't like the particular track of this, because there's not really very many steering currents that would make sense to this. And even with a pretty strong Bermuda high over here at this current point, I wouldn't see it just jerk off to the west at an almost 90-degree angle like that. It would have to be more gradual unless something unexpected happens, but we'll have to see what happens. But I'm not really liking this GFS run in particular, although it does have some potential low pressure developing near the Bay of Campeche. At least we're seeing a few signals of that, so we're going to want to pay attention to that. But by and large, I'm not liking this GFS run. Let's go ahead and show you the CMC now. Here's the 12Z Canadian, has the system crashing in as a potential hurricane on the Mexican coast. Then it moves into the Bay of Campeche, and potential organization and development does take place. But the thing is that low level circulation is just very much hugging the coast, according to the CMC. So we're going to want to see how that will pan out as well. Shifting over to the Icon as well, let's go ahead and take a look at that. Icon has this system moving further to the west a little bit, crashing into Mexico, and then kind of the convection that moves into the Bay of Campeche doesn't really develop that much, according to the operational. So it's kind of a sticky situation. A lot of the operational runs are wanting this to move further to the west, but if we do see the system develop further to the north, like we're seeing with satellite imagery right here, then we're going to have a situation where those operational runs are going to have to reprogram everything, and they're going to have to initialize it at the point of where the LLC drops, the low-level circulation drops, which I personally think is going to be north of about 10 degrees compared to south of 10 degrees, like some are suggesting right here. So we're going to want to pay attention to that. But ultimately, that's kind of the threat we're looking at for the Bay of Campeche. Let's go ahead and also look at some of the conditions as well, just to kind of analyze that, as well as analyze a few other areas that I'm paying attention to as well. So here's what we have going on. We'll start with the global sea surface temperatures. Water temps are more than warm enough for tropical development at this current stage. This is early June across much of the Atlantic. You could say that this looks like early August in terms of its average right here, particularly in the Gulf and the northwestern Caribbean as well. And where the system is 94E, it's off the coast of Nicaragua. It's over 29 degrees Celsius or 84 degrees Fahrenheit for those of you living in the United States waters. And how it's going to move into even warmer waters, crash into Mexico, and then move into the Bay of Campeche if it does move that far to the east. And look where it runs into. 29 to 30 degrees Celsius waters. It crashes into 30 degrees Celsius waters right away, which is very concerning if it does move that far east. And the ocean heat content over there has been surging as well. Let's go ahead and take a quick look at the OHC according to the University of Miami. This is what we had yesterday for the OHC. This is what we have today for right here. As even over the last couple of weeks, we can go to June 1st right here. We can show you that this has been surging right here. OHC on June 1st, seeing some 50s, 60s right here. This is where we're at right now. A lot more OHC everywhere across the Gulf. The loop current is cracking 150 OHC once again, and you're seeing a lot of regions in the northwestern Caribbean cracking 125, 130 OHC, and that's a very concerning thing to also pay attention to as well. So that's kind of the gist of what we're looking at right here. We're looking at more favorable water temperatures and water conditions for tropical development to take place. And even still, as I've looked at this, normally you would think, okay, maybe the wind shear and the dry air are going to play factors into this. we're going to have less of a dry air problem this time around. Let's go ahead and go to the 0Z Euro just to show you this. The relative humidity is actually not going to be that big of the problem. It's mainly going to be a wind shear issue that mainly drives it, because look at this. You're seeing a moisture surge across the Western Gulf. No dry air really impedes it for quite a while until like about 7 to 8 days out right here, mainly due to the Sahara dust moving in. But that's kind of the situation you're looking at right there. And then looking at the wind shear as well, taking a quick glance at that. Okay, not the averages, but I just want the regular wind shear. Wind shear is going to be the main problem. And looking at this, you do see a pocket of low wind shear as the system is supposedly crashing into Mexico and moving into potentially the Bay of Campeche. But as time goes on, that wind shear starts to move further and further to the west, and that's going to shear the heck out of it. As well. So that's mainly our main inhibitor for tropical development right there. It's not dry air, it's actually the wind shear this time around. So we're going to want to pay attention to how this will evolve, and we'll continue to keep you updated here on the Pat's Path Predictor channel. But now let's go ahead and shift over to another area I am concerned about, and that is the main development region. Here's what we have going on with the European tropical cyclone strike probabilities. This is the weekly mean, and we have this for Monday, June 23rd to Monday, June 30th, 2025. This is the risk for this region over here. And what we are looking at right here, especially in the main development region, particularly the eastern half of the MDR, you're looking at some probabilities, at least 10 to 20% probabilities in some of these areas right there. So what's the main thing right here? What's driving these probabilities? That's the main thing I'm looking at, because on one hand, I look at this and I'm thinking, okay, this may be some noise that we want to pay attention to, but right now I'm not entertaining this. But on the other hand, they have to be based off something. So we can actually look at some of the model runs and see, okay, what kind of conditions are we looking at? Water temperatures are a constant at this point, so what is the wind shear and what is the dry air looking like over there, as well as the vorticity potential. Let's go ahead and take a quick look at the wind shear, 200 to 850 millibar shear right here. We actually have it pulled up for you right now, as a matter of fact. It does look like, and we talked about this on stream last night with Ethan WX. Shout out to you. Thanks for coming on the stream. We really appreciate you coming back and all of that after a couple of years. It's so good to have you back, man. But anyway, we got a decrease of shear starting around June, actually around June 22nd. You're noticing shear leaving the parts of the MDR region, less shear overall across a lot of these regions for that week until around the 29th or so, when wind shear does start to impede. So that might be a potential opening if you looked at water temperatures and wind shear by themselves. But we're also missing one other factor. What's the Sahara air layer going to look like? Let's take a look at the Sahara air layer. It's going to be pretty interesting, to say the very least. For that week, at least the northern two-thirds of the MDR is going to be trapped within that Sahara air layer. Yes, you're going to see some moisture moving across much of the region, but that's going to be kind of intertwined with the intertropical convergence zone. So you're going to want to monitor this, and you're going to want to see how this will pan out. But looking at the anomalies again, this is also a bit concerning, because you're looking at these anomalies, you're looking at these precipitable water anomalies, you're looking at a more moist environment than average. And I think that's why the European ensembles are picking up on this, because these are climatological. These are run on climatological data and a few other factors as well. Climatologically, we're looking at a more moist MDR, at least the more moist southern half of the MDR than average. And I think that's the main reason why the European is tagging a potential possibility of that happening there. Even the European operational does have a kind of a low pressure system hovering over there at 324 hours out. But at that point, it's too early to determine what's going to happen. So we're going to have to pay attention to that. Also going to take a quick look at the vorticity to see what potential stuff we have going on there. Definitely, there is some vorticity that does hang around over there, but by and large, will this generate tropical development? Too early to determine, but we'll keep you updated on that. And now that that does pose a potential risk due to the climatological runs as well, and the fact that we're seeing lower wind shear as well. That's an area that you're going to want to keep close tabs on going forward. So we will continue to update you on that, but be sure to like the video and subscribe to the channel if you are new. The goal, as always, is to get more people engaged with weather. If you'd like to help out, hang out, or ask us some questions, be sure to join the Storms United Discord server. The link to that is in the end screen. And with that being said, have a wonderful day, guys. Stay safe.